Hello, everybody. So we are starting our second unit, which is on polynomials. And this one's going to go much faster than the line unit. And then after this, we will have our midterm. So just to give you a heads up as to our future. So polynomials, I know you've seen them before. This is not really a mathematical definition, but it'll serve our purposes. If you're adding or subtracting a bunch of terms, and those x values have exponents that are positive integers, then that is a polynomial. So this is a polynomial. We're going to be working on polynomials for the next several weeks. This one is not a polynomial, but why not? Well, you've got numbers in front as the coefficients, that's fine, but this is the first thing that tells us it's not a polynomial. Polynomials will not have an exponent on a variable that is not positive, not a positive integer. So -1 right away breaks it. But these two also screw it up because um, the square root of x is the same thing as x to the 1/2. So that's not an integer. And 4 divided by x squared is the same as 4 times x to the -2nd. So that's not a positive. That's an integer, but it's not a positive integer. And there are some things that are true about all polynomials. One is that they have a domain of all real. You will be able to plug in any number that you've ever thought of into a polynomial. Any number, well, all numbers go into polynomials. And they are continuous, which is an important math concept to know. Continuous means that you can draw it without ever lifting up your pencil. So lines are technically polynomials of a degree 1, so it's just x to the first. But we studied lines for so long. Now we're moving on to polynomials that have a degree 2 or higher. So these three are all polynomials. They have a domain that goes on forever. They have smooth curves. If they do turn around, but they will do in like a smooth way, not a jagged way. And they are continuous. If I were to give you a purple crayon, you could draw this whole polynomial without lifting up your pencil. These 1, 2, 3, 4, 5 functions, they're all functions. They all pass the vertical line test, but they're all not polynomials. Why not? Why is it this one a polynomial? It's smooth, but it doesn't have a domain of all real. It stops right here. This red one, it doesn't have a domain of all real. It has a domain from -12 to -2, but also it has jagged corners. So that's so two reasons why this is not a polynomial, the red one. The green one does have a domain of all real, but so why isn't the green one a polynomial? It is not continuous. To draw this green function, you'd have to lift up your pencil to draw this line, and then lift up your pencil to draw this next line, and then lift it up again. This blue one is intended to have a domain of all real. It goes forever to the left, forever to the right. Why is it this a polynomial? Because of that jagged edge right there. Polynomials have smooth curves. And we're going to do three main things with them early on: add them, subtract them, and multiply them. So first, we're going to add them, subtract them. And just some quick terms right here. You've got 1, 2, 3, 4, 5, 6. What? What are those called? Those six things. Those six things are called terms. Terms are essentially separated by plus and minus signs. If you're adding or subtracting something, then you're adding and subtracting terms. Okay? And then you've got two groupings. There are parentheses around two groups of three. So those are just groups of three that are grouped together. Nothing too consequential there. But then just because you see parentheses does not mean that you're multiplying. It just means that they're grouped together. Here, this group on the left and this group on the right are being added together. So we have to always be aware of the operation. What are we doing? This group of three is being subtracted by this group of three, etc. So then how do we continue here? Well, remember we have six terms here, and when we're adding or subtracting, we can only add or subtract like terms. And the two blue underlined are like terms. 10x squared means I literally have 10 x squares. And 5x squared means I have 5x squared. Well, how many x squareds do I have? I've got 10 over here and 5 over here. I've got 15x squared. So that is the first combination. I have 10 plus these 5. That's a total of 15. Here I've got 3 x's, so that's x, x, x. Here I've got 1x, and I'm adding. So I have 3 plus 1. That's a total of 4x. And then lastly, I've got 9 what? I've got 9 ones, and I've got 4 ones, and I'm adding. Well, if I take these ones and if I add these ones, I have a total of 13 ones. So that's just plus 13. So here is our final answer. Subtracting is just the inverse of adding, but it follows a lot of the same rules. We can only subtract things that are like terms. I've got a squared, an x to the first, and then a bunch of ones. On the right grouping, I've got a squared, an x to the first, and a bunch of ones. Well, like you can combine things that are the same degree. So again, with this grouping, blue can combine with blue. But be careful with subtraction. It's slippery. You've got negative 3x squared minus negative 2x squared, which was what is written right here. So that minus and negative is going to become plus. And then you got negative 9x minus negative 4x, which is what's written right here. And then 5 minus 7. Combining like terms, this is negative 3 plus 2, which is negative 1x squared. This is negative 9 plus 4, so it's negative 5x. And this is positive 5 minus 7, which is just negative 2. So our final answer is that. Final answer there. Final answer there. Now, when you're showing work for a quiz, you don't have to show all the steps that I'm showing. You do have to show some steps, especially when you multiply. So here, notice you've got a group on the left, you've got a group on the right. I know that because I've got parentheses that groups things together. And there's nothing I can see in the middle here. There's no plus, there's no minus. So that means it is multiplication. I need to take the group on the left times the group on the right. Now, whenever you have addition or subtraction, is used together with multiplication, used together with, oops. If ever addition or subtraction is mixed together with multiplication, then you have to distribute. Distribution is its own operation. It only happens when you're adding and multiplying. And that's what's going on here. We're definitely multiplying, but the adding and subtracting are in the two groups. So we have a lot of work to do. We're going to take this first term and distribute it to these three. So this x squared times x squared times negative 2x, x squared times negative 1. And when I do that, I would get that. I get x squared times x squared plus x squared times negative 2x plus x squared times negative 1. So I have to do those three. But there's more. I have, now that if you do that, you have distributed the x squared. Now we have to distribute the 2x because everything on the left is being distributed to everything on the right. So the 2x has to multiply by x squared, 2x times negative 2x, 2x times negative 1. Now, if you do that, you have distributed the 2x. And that's what that looks like. 2x times the x squared plus 2x times the negative 2x plus 2x times negative 1. And then finally, you had to distribute the negative 5. So negative 5 times 2x, negative 5 times negative 2x, negative 5 times negative 1. And we get all of that. So another thing that can help us perform well here is that you got 3 terms on the left, 3 terms on the right. That's going to end up with 9 terms. You're going to have 9 things. And I do have 9 things. This is one thing. Remember, terms are separated by pluses and minuses. So that's one term plus, okay, here's another term, plus, here's another term, and so on and so on. There are 9 of them because you take 3 on the left times the 3 on the right. That's 9. And then now it's just a matter of multiplying correctly. X squared times x squared is x to the fourth. X squared times negative 2x is negative 2x to the third. And this is negative 1x squared. 2x times x squared is 2x cubed, etc., etc. And now you're not multiplying anything. The only operation I see minus and I see plus. I don't see any other operation. So now you revert back to just adding and subtracting like terms. So there's only one x to the fourth from what I can see. So that just pops down right there. I've got an x to the third here. Here's another one, and there are no more. Well, those two cancel out. Negative 2x cubed plus 2x cubed is 0. They're opposites. So that's why I've got no x cubed in my final answer. Negative x squared. So I'm looking for now the x squareds. Here's another one, and here is another one. So negative 1x squared and negative 4x squared together make negative 5x squared. And another negative 5x squared make negative 10x squared, because negative 5 plus negative 5. Or just go to your calculator and do negative 1 minus 4 minus 5, and you'll have minus 10. And then finally, I've got x to the first, so 2x to the first, positive 10x, so that's a positive 8x. And that is our final answer.